Why are powerful planes from the US, UK, and Australia gathering in the dark sky? What makes the F-35 different from other planes? How does its super stealthiness help in battles? Why is its computer power so important? What are the alarms for it? Why are enemy planes approaching? How does the F-35 change the way we fight in the sky? Is it worth the cost? From here, it seems the fastest US fighter jet is going to shock Russia. Fourth-generation fighters hailing from all three nations, including F-16 Fighting Falcons, F-15 Eagles, and Eurofighter Typhoons, coordinated with E-8 Joint Stars command and control aircraft. As their stealthy escorts, both F-22 Raptors and F-35 Joint Strike Fighters surveyed the battle space. Soon, cockpit displays in each aircraft began to light up and alarms sounded, indicating that the formation was being painted by multiple radar arrays tied to surface-to-air missiles and inbound fighters. Enemy fighters sporting the color schemes of Russian Su-30s began to close in. On the last week of a red flag exercise, we really throw everything we have at the Blue Force and replicate the toughest adversary possible. Ultimately, the F-35 fighter jet won that day, breaking down one of the world's most advanced air defense networks and relaying the data to missile-packed fighters like the F-16. The F-35 can fly at speeds as high as Mach 1.6 and can carry an internal payload of 4 weapons without compromising its stealth. But it's not the F-35's firepower that really makes the difference. It's the computing power. It's why F-35s have come to be known as quarterbacks in the sky, or a computer that happens to fly. There's never been an aircraft that provides as much situational awareness as the F-35. In combat, situational awareness is worth its weight in gold. But for nearly its entire life, many have debated whether the F-35 is a game-changing platform or a case study in the excesses of the Pentagon's weapon acquisition process. It turns out it's both. A 21st century fighter jet, it would also leverage the same stealth technologies found in F-22. With a laundry list of requirements from the US Navy, Air Force, DARPA, and soon the UK and Canada, the Joint Strike Fighter needed to replace its at least 5 different aircraft across all the different services, including the high-speed interceptor F-14 Tomcat and the tank-killing close air support A-10 Thunderbolt II. While replacing all of these aircraft with one plane would theoretically save money, the long list of requirements led to a landslide of expensive complications. In fact, while the X-35 was still competing for the contract, many weren't sure such an aircraft could even be built in significant numbers. Designed from the ground up to prioritize low observability, the F-35 may be the stealthiest fighter in the operation today. It uses a single F-135 engine that produces 40,000 pounds of thrust with the afterburner engaged. Capable of pushing the sleek but husky fighter to speeds as high as Mach 1.6, the aircraft can carry 4 weapons internally while flying in contested airspace when flying in low-risk environments. The F-35A also comes equipped with internal 4-barrel 25mm rotary cannon hidden behind a small door to minimize radar returns. The standard weapons payload of all 3 F-35 variants includes 2 AIM-120CD air-to-air missiles and 2 1,000-pound GBU-32 JDAM guided bombs, allowing the F-35 to engage both airborne and ground-based targets. The cockpit of the F-35 forgoes the litany of gauges and screens found in previous generations of fighter in favor of large touchscreens and a helmet-mounted display system that allows the pilot to see real-time information. This helmet also allows the pilot to look directly through the aircraft thanks to the F-35's Distributed Aperture System (DAS) and suite of 6 infrared cameras mounted strategically around the aircraft. If you were to go back to the year 2000 and somebody said, "I can build an airplane that is stealthy and has vertical takeoff and landing capabilities and can go supersonic," most people in the industry would have said that's impossible. Tom Burbidge, Lockheed's general manager for the program from 2000 to 2013, told the New York Times, "The technology to bring all of that together into a single platform was beyond the reach of industry at that time." While both the X-32 and X-35 prototypes performed well, the deciding factor in the competition may have been the F-35's complicated short takeoff and vertical landing (STOVL) to fly it. Because the US Marine Corps intended to use this new plane, America's new stealth fighter had to be able to fill some vertical landing, short takeoff role. The lift fan design used in the X-35 connected to the engine at the back of the aircraft to drive a shaft that would power a large fan installed in the aircraft's fuselage behind the pilot. When hovering, the F-35 would orient its engine downward, not unlike the X-32, but it would also pull air from above the aircraft and force it down through the fan and out the bottom, creating two balanced sources of thrust that made the aircraft far more stable. It also helped the F-35 notch a win in the looks category. You can look at the Lockheed Martin airplane and say, that looks like what I would expect a modern, high-performance, high-capable jet fighter to look like. The future looked bright for the newly famed F-35. The F-35 Lightning II, a cutting-edge fifth-generation multi-role fighter aircraft, is the flagship creation of Lockheed Martin Corporation, poised to redefine modern aerial warfare, widely adopted by the United States Air Force, Navy, Marine Corps, and allied nations. This exceptional jet embodies a symphony of revolutionary features and capabilities that place it at the forefront of military aviation. At the heart of the F-35 Lightning II's design lies its remarkable stealth capabilities, a result of meticulous engineering and the strategic use of advanced materials. The aircraft's distinctive form and composition minimize its radar cross-section, conferring it a remarkable ability to elude enemy radar systems and remain virtually invisible during missions. An exceptional hallmark of the F-35 is its sophisticated sensor fusion technology. This groundbreaking innovation seamlessly integrates data from diverse sources, empowering pilots with an unparalleled situational awareness. The F-35's velocity is another awe-inspiring facet of its design. Its top speed, reaching a remarkable Mach 1.6, equates to around 1,200 miles per hour, ensuring rapid response and maneuverability. Notably, the F-35B variant, a versatile iteration, boasts vertical takeoff and landing capabilities, rendering it capable of operating from austere environments and even amphibious assault ships. The aircraft's cockpit is an oasis of advanced avionics, crowned by the immersive helmet-mounted display system. Providing a 360-degree view of the surroundings, this technological marvel enhances pilot awareness, facilitating split-second decision-making. This dovetails perfectly with the F-35's multifaceted role as both an air superiority and ground attack platform. Crucially, the F-35 Lightning II's operational effectiveness extends to network-centric warfare. However, it is important to acknowledge that the broader F-35 program, encompassing developmental, production, and maintenance expenses, has invited scrutiny and debate due to its substantial costs and developmental delays. With estimates surpassing $1.7 trillion over its lifespan, the F-35 program has prompted extensive analysis of its fiscal implications. In essence, the F-35 Lightning II represents a paradigm shift in aerial warfare, melding stealth, agility, sensor fusion, and network-centric capabilities into a singular platform. While controversies persist regarding its price and development, its undeniable contributions to modern defense underscore its position as a pinnacle achievement in aviation history.